So in the beginning, it's good to just pay attention and go through some data and write down what is wrong. Whenever I go through that exercise, everything comes into focus. You start to get an idea of what metrics might be interesting. Because you can't test everything. There's too many components and too many things. But if you start to focus on what is actually going wrong, you can get a lot of intuition from doing the error analysis.
Hi, I'm Austin Parker.
I'm Ken Rimple.
And I'm Jessica Kerr.
And you're listening to Observability Cast, or o11ycast for short, a monthly series where we talk about how we can make production systems more observable, more reliable, and easier to maintain.
o11ycast is brought to you by Heavybit, the leading investor in developer-first startups. For more information, visit heavybit.com.
If you're interested in being a guest on this show, or if you have a specific topic you'd like us to dive into, you can reach us on Twitter at o11ycast. That's at o11ycast.
So, Hamel, why don't you introduce yourself?
Sure. I'm Hamel Husain. I have been working on machine learning for over 25 years. I've worked at a lot of different tech companies like Airbnb, GitHub, and a bunch of other startups. I've been working on large language models for a really long time. I've led research at GitHub called CodeSearchNet, which is a precursor to GitHub Copilot. At some point, I took on independent consulting, helping people work with AI. So that's where I met Philip at Honeycomb, and I helped Honeycomb with their first natural language query product, which was a lot of fun. People know me a lot from open source, so I've done a lot of work on machine learning tools and data science tools in infrastructure. So that's kind of a parallel kind of thing that I've worked on as well.
Sure.
Also, no money in that.
Yeah, for sure.
But some glory.
Yeah.
And we have Philip here too. So, Philip, why don't you let people know who you are here?
Yes, hello. Yeah, I'm Philip. I work for Honeycomb. I'm a principal product manager. Been at Honeycomb for a little over 3.5 years now. Prior to that, had been at Microsoft working in developer tools for several years, and didn't really get into AI until like a couple of weeks before ChatGPT launched. I'm proud to say I wrote the document talking about how we should do AI at Honeycomb before that thing actually came out. But that was because I had been using GitHub Copilot prior, so it's not it's not like I saw something that nobody didn't see. And then, as Hamel mentioned, I worked with him and, then eventually some others as well within Honeycomb to build our first AI feature called Query Assistant, which lets you write queries using natural language. And it was sort of this very targeted feature for new users to come on board. And, they don't really necessarily know how to do observability queries, but they can describe what they want in natural language, and kind of works pretty well for that. And now I'm heading up our AI efforts across the company.
So I guess certainly from a telemetry perspective and monitoring data, I know that a lot of these startups doing open telemetry, for example, are starting to use AI in their tools. What are some of the challenges that you run into in, analyzing streams of data with AI?
So as far as AI is concerned, it's pretty nascent of a field. A lot of people have not been introduced to the concept of traces and spans until now. A lot of people have not been working on distributed systems or not been working on these kinds of things that are working on AI. I would say it's so nascent that people don't really know where to begin. So a lot of folks don't have any instrumentation at all on their systems. And, usually that's the first starting point is, okay, how do we instrument our systems, properly? And kind of the first entry point to doing that is there's a lot of LLM-specific observability and evaluation tools and vendors, some of them open source, some of them commercial. And one easy way to get started is they often have a wrapper around popular SDKs like the OpenAI SDK, Anthropic SDK, whatever. And you change one line of code and you get a bunch of telemetry on, language model interactions. And so that's where it starts. People then can have at least some view and record of the interactions that their application or the users are having with AI. And then the question quickly becomes, okay, what do you do with that data? And people struggle with that. Right now, the most common failure mode is people reach for off-the-shelf metrics. So a lot of the tools and vendors out there, they have off-the-shelf metrics like hallucination score, conciseness score, helpfulness score, whatever. And it's very tempting to say, let me just create a dashboard with a bunch of metrics, those off-the-shelf metrics, and it feels like you are doing evals or evaluating your system, and it feels like you have some level of observability, but you really don't. You don't really have anything because off-the-shelf metrics, for the most part, don't do anything. They actually can be very harmful because they just add a lot of noise and confusion to the picture. And often they don't correlate with what's actually interesting and what should be prioritized and so on and so forth. People don't know where to start. There's a notion that, hey, this all seems very tedious. Can this just happen automatically? Can I just plug in a thing and have something magically tell me what my problems are and what I should focus on? And that's where people get into trouble with these off-the-shelf metrics. And that's when people reach out to me at this point, either when they don't know what to do to begin with, or they've done some instrumentation, but they don't really know what to do with it.
What's interesting about it to me is that it's in a lot of ways a mirror of what you see, I think, with most like observability and monitoring tools. People will go, I'm bringing in Kubernetes because my boss said we need Kubernetes. And so we go and we sign up for whatever. And they say, here's your Kubernetes dashboard. And it has these dashboards and metrics and alerts and all of this stuff just packaged out of the box. And you install that and you go back and it's like, yep, we're good now. And it's such a common pattern that it's tough to say, right? Because people still do this every single day. Like it's one of the biggest things, as someone that's been working in observability for, like 10 years now, and seeing it from like almost every side of the equation, one of the biggest, I think, impediments to like innovators in observability space is that people will say, it's like, well, where's the thing that just tells me what I need to know? And it's super challenging to kind of start with, well, that's kind of a you question, right? Not a me question. I think AI, people are certainly more susceptible to that pattern in AI because it is such a different kind of technology component than we're used to in the industry.
I think that's right, yeah.
I would actually love to hear this from you. Like how, you can't throw a rock without hitting some very strong opinions about AI, especially in the techie community these days. What I want to know is like, how do you, thinking about AI as like a building block, right? Thinking of it as a component, like how do you describe that to people? Like how do you kind of help cut through the noise, as it were, around AI and just be like, look, this is a tool or this is a component of a system and not like some weird world-ending thing?
Yeah. I can answer that question in multiple ways. I can start with like the observability angle, actually. So like a lot of people, they have AI, they've instrumented it, and it's pretty overwhelming to some people. They're like, well, what do I even look at? What do I test? Or where do I begin? The outputs of the LLM are stochastic, and I don't really know if I can test it. If I use another LLM to test it, how do I trust that LLM? All these questions, and quickly people become paralyzed. Now, thankfully, there's been a regime where we've already dealt with a lot of these things. So in classic machine learning, before LLMs, we had the same issues. Like we have models that are making predictions of various kinds. Those outputs are stochastic and changing. And you have to figure out, okay, like it's not a deterministic system. How do you evaluate it? So there's some pretty basic techniques. One technique that cuts through a lot of noise very fast is getting people to do something called error analysis, which is a very fancy term for looking at your data systematically. And really what all that means is, you start looking at your traces and you start with just writing notes, any issues that you find. could start with like 100. There's no magic number, whatever. Like just start looking at data. Every time that happens, so like we've done that in machine learning for a long time. It seems counterintuitive. It's like, how can that be helpful? It seems like you're picking up grains of sand on a beach one at a time. Like, how can this ever be a fruitful exercise? But it is. It's an extremely fruitful exercise, probably the most fruitful exercise you can engage in a system like that. And there's different ways to sample and things like that. You can get fancy with it. But to begin with, starting to look at data and interactions and like becoming really familiar with the kinds of failure modes that you're experiencing.
Are you looking for patterns, like common failure modes?
Yeah. So in the beginning, it's good to just write notes about, if things are wrong. Because you don't even know what the common failure modes are in the beginning. You don't even know what those categories are or what those are. It's important just to pay attention and go through some data and write down what is wrong. And then you can use like an LLM to categorize those notes later.
Ooh.
Or you could do something like that. But like whenever I go through the exercise, everything comes into focus. For example, like what kinds of failures are happening the most? What kinds of things should you be paying attention to? You start to get an idea of what metrics might be interesting and where things might be failing. And you start to get a sense or a smell of, okay, like this is what I need to work on. And it brings everything into a lot of focus. Because you can't test everything. You don't want to measure everything. There's too many components and too many things. But if you start to focus on what is actually going wrong, you can get a lot of intuition from doing the error analysis.
This reminds me a lot of my reading about social science research and grounded theory.
Okay, go on. Yeah.
Oh, Brené Brown describes some of her research techniques that involves interviewing people and then going through the interview transcript and doing what social scientists call coding, which is first noticing themes that come up again. And then you go back and you like tag, we would call it tagging, excerpts that match each theme. And then you can like put them together and look for patterns and get new questions and then go research those questions.
Yeah, that's it. That sounds remarkably similar to what this is. It probably is like almost the same thing. And there's a structured way to go about it. There's a way to navigate the data. Like when you start to become more familiar with your data, you can segment it by, different dimensions and things like that. Probably same thing you do in observability space. And, just looking at data, the people, I think amongst the machine learning practitioners out in AI right now, we're all repeating this phrase, like look at your data constantly, beating people over the head with it because it is it's pretty uncool, but it's probably the most effective activity you can do.
We think it's not rigorous. Like as developers, we think if we have to use our human eyes to look at it, then well, it's subjective.
Yeah.
But you said there's structured ways. Yeah. And the social scientists have studied this for decades of there are rigorous ways to do research on individual experiences and their descriptions.
Yeah. And the key is to make that process like low friction, right? Because you can imagine looking at traces can be painful. Looking at hundreds of traces, like you want to make it as smooth as possible and as enjoyable as possible. So you can page through those traces easily and write notes easily without clicking around at a bunch of stuff, without navigating through a bunch of stuff.
Without reading very large text fields in a box this big.
Exactly, yeah. And you want to be able to render nicely. So like if your traces contain, let's say, I don't know, markdown or code or whatever, it's human readable so that you can just flip through it really fast because you need to make it enjoyable, essentially. And that's actually really interesting. Like at this point, as of today, I'm still building custom tools to view data quickly, even though we have observability tools for LLMs, even though we have things like annotation queues. A lot of times they're not dialed in enough. Like they still a lot of times a little bit too much friction or something like that going on. They're getting better. I talk to a lot of them on a regular basis, so they are getting better. So that's the key part. And then doing some data analysis on the error analysis. So like, okay, you've done a bunch of error analysis. You can take what you've learned and then you can do all kinds of stuff. You can do do data analysis on like your notes and those categories and that coding that you describe. There's different terms you can ascribe to it, but it's really to figure out, okay, what's most important. You can think about writing tests. You can do all kinds of things. And that exercise requires some amount of data literacy. You have to be comfortable with manipulating data, thinking about data, have some sense of maybe navigating data. It seems trivial, but a lot of people don't have these intuitions. Like, oh, how do we summarize these notes? Or how do we summarize these things? What do we look for? I think I have a intuition that's probably the same struggles that you have, you know, in non-AI as well, based upon what Philip has told me.
Yeah, I think that's what I was trying to get at earlier in a lot of ways, right? Like, ultimately, the observability problems are sort of generic observability problems, right? You have all of this data about system state, and you need to parse it and understand it. And it's maybe a little more difficult because these are non-deterministic systems. And so that makes your life harder if you're trying to say, like, I think that's the appeal of the out of the box, hallucination rate metric or whatever, right? It's this comforting idea of like, oh, there is some sort of best practice here. And that's just not the case, I think, in AI. And I'm not sure it'll ever be. Maybe I shouldn't say ever be, right? Like, I think when you get down, I think as well, we've seen a trend in the industry getting towards smaller and more purpose-built task-oriented loops for AI as like a part of functionality. So presumably eventually you could get there. The other interesting thing is like, where it does change is the type of data, or not the type of data, but maybe the type of things that are in the data, right? Like traditional observability tools tend to be, they focus on like density, and I have like all of these small points. And then when you get into AI, you're suddenly dealing with like just this tremendous amount of stuff inside each data point, like wide events or whatever. And I'm looking at, 1,000 tokens or whatever in markdown format, and like the tooling just isn't there to like let you display that in a conventional way.
Yeah, definitely.
Yeah, and I love what Hamel said about once you have the categories, you can ask an LLM to categorize things. So you could get the LLM to tag and like highlight pieces of the many character outputs that look relevant to the problems, and then you could spot check them.
Yeah, and you can get LLMs to add dimensions to the data. Like, for example, you want to slice and dice that data according to what's relevant to your business. So like, what channel is the customer talking to you in, or what kind of request is this, or whatever. And if you don't have that, you can try to get LLM to help you. Say, okay, like categorize this interaction according to XYZ, which can help with data analysis.
So that can scale your error analysis of looking at 100.
Yeah. Well, it can make it easier to navigate the data. But it's important to start with, people are always extremely surprised when I tell them, okay, we're going to look at, 100 examples. And then after they're done, they're like, wow, I learned so much.
So to kind of make some of this concrete, when we built Query Assistant back in early 2023, I mean, it's not that there's a ton of best practices for LLMs today anyways, but there were definitely a lot less back then. So we did our best, knowing very well that what we were going to launch at first could totally fail and be a disaster. So we're like, okay, like we have to be willing to rip this feature out if it's not actually doing what it should. But how do we know it's doing what it should? Well, there's like a million ways to do it, but what we ultimately landed on was like, okay, well, let's not try to focus on creating the perfect query for someone yet, because if they're a newcomer, they may not be the best judge of like what an ideal query for their question is. And it's like more important that they engage with the product and iterate than it is that like one shot perfect query, one and done, out of the system. So our success metric there was, can we actually create a runnable query based off of their input text? And you might imagine some people type in some bullshit and like, there's no way that you can make a query. Like someone asks a question about like, what's the capital of Michigan? It's like, okay, yeah, that's going to fail. I don't care about that, right? Like I care about when you're asking about like how many things are there, but then you create a count distinct inside of Honeycomb that's like structurally incorrect. And so then like we can't actually run that query. And it's like, okay, like we actually failed to do the job here. And kind of to what you were saying earlier, Hamel, there were like, it was so evident just immediately. We just created groupings of like natural language input, the error, if it existed, and what the output was, and just grouped by that. And as you might imagine, there were a lot of different groups, but like literally at a glance, I would say within like 3 minutes, I would already have a sense for like what kinds of things are generally failing right now. Like it was so simple to just sort of look at it in just like a table of data and then be like, oh, cool. All right, this is a category of problem. We're going to focus on that today. And then we fix it and we just like run the query the next day, or like we think we fix it, right? Because we have the full trace, like we have the exact prompt that was sent. So like we could usually reproduce what the actual bad output was. So we could sort of iterate on that in dev, push it, wait like a day, run the same query and be like, do we still see that same failure case? And just repeat this process. And over time, like most of the time, it would just work and like actually do the job. And there were a lot of these concrete cases where like the fix wasn't even like prompting. It was like, oh well, maybe it could be prompting, but actually we have all the information in the response that the model gave us to just like change it programmatically to be correct.
The same way as a person, if I looked at that query that it was trying to run, I would just type it in correctly instead of the way they said.
Yeah. So like using the count distinct one as an example, a very common failure pattern, weirdly enough, was it would do a count distinct as the operator for a visualization clause, and then it would have 2 columns instead of 1. And so we're like, well, which one do we pick? I don't know, pick one, whatever. Like, what's the worst that's going to happen? And like, actually, we know the type of the column. And so like, we know that you count distinct on a string is nonsense, at least in the current Honeycomb type system. So we just pick the one that's not a string. And the first one we see that's not a string and add that in there. And we did this a few times and, tried to make notes. And we also added into our instrumentation when we applied a particular programmatic fix so that we could track systematically like how often we run into this problem so that we could then assess, okay, is this like something that continually happens, which indicates, no, we really do need to use prompting to like fix this? Or is this just a thing that happens every once in a while, much lower priority for us to like deal with? And that was able to wipe out a tremendous amount of the errors alone so that like the prompting that we did have to do was like very narrowly targeted on like, okay, we can't programmatically fix this. And this is just a fundamental flaw in how we're asking the model to do something. And over time, like the feature just got stable to the point where like it's still on the product today. And it's what new users, when they sign up for Honeycomb, it's like we literally point them to like, hey, type in a thing, look for what you're asking for. And like it usually works.
It works really well.
Yeah, it works pretty well. I wish it could work a lot better. There's a lot of, regrets that I have about like how I built it and all that. But like, I think it really speaks to that. It was a way of us looking at our data, but like it wasn't hard. And in fact, it was really, really easy because everybody internally at Honeycomb uses Honeycomb to like observe things that are happening on the live Honeycomb product. So it was in a place where every engineer like knew how to look at that data and like page through all the different cases. If that wasn't the case, I'm sure we would have maybe even just gone with like a Google Sheet or something like that. Something just as simple as that, like whatever is the easiest for people to look at, it just makes the problem so apparent, like immediately.
That's great. Like you didn't have all these bullshit metrics. You had things that actually were going wrong specific to you.
Like corresponded to reality.
Yeah. No, I am actually curious though about when it is appropriate to roll something up into a metric that you do want to track long term. And like my intuition, and I don't necessarily know if this is true, but my intuition is that this would have to come after you do data analysis and you find that like, okay, we can derive a particular metric that if we monitor actually does tell us something meaningful.
Yeah.
But I've never done that before.
Yeah. So when you do your error analysis and, you see failure modes that are not trivially resolved. Like, for example, there's a lot of errors you'll see that, oh, this is just an engineering problem. Like, I don't have the right API key in here or something like trivial. You'll have some errors like, oh, that's kind of really difficult. This is something I want to tackle over time. And, you can design a metric specific for the error. And when you just like an example of that is, okay, like I'm working with an AI leasing assistant for property management companies right now. And their AI assistant gets dates wrong often. They just make mistakes in dates. Like a user will ask for, hey, I need something next year, and it'll give you the date for this year or whatever. That's a failure mode we want to avoid. And you could construct like a data set and some ways of measuring that. Like if your prompt is hitting these different errors. And so like there's many different kinds of errors. There's ones that you can test with like assertions. There's ones that you might need to use the LLM as a judge. So that date thing is kind of, you can construct a data set with a golden or expected output, and you can do like almost an assertion against it. There's other errors where it might be harder. So, for example, you and I, Philip, when we were working on, we did an exploration of fine tuning a model for the natural language query assistant. We had an LLM as a judge that we used to figure out, okay, is the query good or not? Because that's subjective. Like, is it good? Like, a query can be valid, but is it good? And so, LLM as a judge is a very interesting topic. It's like, oh, that's interesting. You can use an LLM to judge another LLM. Like, how does that make sense? And the way that works is you shouldn't just use an LLM as a judge blindly. You have to do some analysis of how much that judge agrees with a human. So what I did with Philip is I had Philip be a judge and write detailed notes about whether a query was good or not. We used like a Google sheet, and he wrote detailed critiques of, okay, this query it's okay, but it could be a lot better. I told Philip to make a pass-fail decision, and then also like detailed notes. And I used what he wrote to kind of do iterative prompt engineering until the LM as a judge became enough in line with Philip. Like there was a lot of agreement between the LM as a judge and Philip. So that's an example where, okay, like you have an LM as a judge and you can have some confidence in it because you did some principled analysis of, okay, this agrees with the domain expert.
So this is interesting because, the hype curve on LLMs and such is that eventually you could get the person out of the loop completely. And maybe someday you can. And certainly as you train things better, you have less and less involvement because you know roughly the conditions that happen. So I'm sure, Philip, you're not looking at the chat windows every single minute anymore. You know roughly what you want to focus on. But in prep for this, I was reading some of your content and I found that really interesting article on Devin. And so,
yeah.
So I guess the point being that without a human in the loop, at least I don't know if there's a human in the loop with Devin, but it seems like there's a lot less human hands-on. It kind of goes and noodles on its own and keeps working on projects. Like, what did you find when you were trying to get Devin, which is basically an autonomous coding agent, to do work for you?
Yeah, I mean, with Devin, it didn't quite work at all. I mean, I think maybe it's like for the tasks that I was trying to do, plus maybe where the technology is at the moment, that kind of workflow wasn't working.
Like the error analysis?
No, this is like this is a little bit of a side quest, I think.
This is a tangent.
Yeah, so Devin is a autonomous coding, I guess I could call it agent. I don't really like to use that word because it's very nebulous, doesn't really tell you what it is, but Devin is a kind of like it's a product. It's like a SaaS that you can purchase. I think it's like $500 a month. You can connect it to a Slack channel and you can talk to it like a human being. Say, hey, Devin, please look at this GitHub repository or look at this issue and fix it, essentially. And then it'll go off for like hours or days and it will iterate on that until it tries to figure something out. And it'll even make a pull request on your GitHub repo. And the idea is you can outsource work to it almost like an intern. And it should be able to tackle tasks that a junior engineer would be able to do. That's the promise. In the article that I wrote on it, we just outlined like, okay, it didn't quite work for us. So I think like at the end of the day, I know the promise is you have, is like, hey, you could take the human out of the loop. The issue is like you have to trust the AI somehow. And the only way to trust something is to check it. Now, the better it is, the less you may check it, right? It's just like anything else in life. Like, okay, this thing is good. I trust it. Every time I've checked, it's like done the right thing. Maybe it gives you more confidence, but you still have to check it. So I don't know if you can completely take the human out of the loop, but maybe as AI gets better, you can take it more out of the loop.
Or look at it as it continually increases our leverage as a human.
Yeah.
Because you do a little bit of error analysis, you teach it to do that error analysis, and then you come back and you check that too.
Yeah.
But we can make it increasingly good and ourselves increasingly powerful.
That's right. Yeah. That's what I was doing with Philip with the LM as a judge is I was trying to basically encode Philip in some rough sense into an LLM with prompting, like all his different rules in his head and whatnot, at least for that narrow problem. So that I could scale his judgment across all the,
You scale his judgment. I like that. We still have to have the judgment. We still have to exercise our judgment. And we can use the AI to scale that.
I mean, this like little snippet of conversation here is sort of the filter function, I think, for people both in the industry more broadly about like what is AI, right? Because at the end of the day, I mean, it's not just a stochastic parrot, but it's a token prediction engine. It's not a replacement for people, but it does augment what you can do significantly. And I think what's frustrating is this is mostly a trivially testable fact, right? Like I've been playing around a lot with Cursor and various like AI IDEs. And I think what's fascinating is that it's gotten good enough that you don't really like for a constrained set of tasks, like you actually don't have to check it that much, or you can build, the Cursor agent mode has gotten really good, I would say, at checking itself. So
it's really impressive. I really am impressed with Cursor.
It's hugely impressive, right? Like, especially if you're using something where the training data is really good and documentation is able to be like fed into the context window really well. So like if you are asking it to make a pretty basic, maybe not even pretty basic, but something that's conventional, right? Like a React web app in Node, not using the latest and greatest stuff, but again, something that easy to write, and most importantly, easy to check, right? Like that to me is the thing that makes Cursor really powerful is that if you are using it, the agent part, then yeah, it'll write something, it'll look at the linter, it'll look at the, language server feedback, it'll try to run it with multimodal capabilities. It can actually just look at, it can pop a browser open and then quote unquote look at what is in the window and continually iterate. And that is all like super duper impressive, right? But as soon as you go beyond what I would maybe consider personal software, you start to see the flaws really, like it starts to break in really non-obvious ways unless you have significant domain expertise very, very quickly. And it feels brittle, it feels bad. Now, 2 years ago, it felt brittle and it felt bad, and we've probably had more or less exponential increases in capability over the past 2 years. I might have won money on the Super Bowl last night, but I am not necessarily a betting man, so I don't know if I would put a marker down on a continual exponential increase in capability. But I do think that, it's still very, very early, but anyone telling you that, Devon is a replacement for an SRE or whatever is blowing smoke up your backside.
Yeah. I don't like on the Devon point, I don't think that's a place for the SRE. I think actually the capability and the UX doesn't lend itself to working, whereas Cursor agent lends itself to working more because it encourages you to guide stuff along the way a lot more and quickly so that even though it's doing a lot, you can still course correct it. Whereas Devon is more asynchronous in nature, where like you kind of say something and completely forget about it.
That's a good point.
And I think I want it to work. I think that's really interesting. Like the async is interesting. Like, let me just, before I go to sleep, let me think of 10 tasks and just like give it to something and see what happens. That's kind of cool. It may work for some things really well. I don't know. You can already see like a little bit of that. There's an async nature to OpenAI operator, but also deep research. Sorry. So deep research is like,
Yeah.
I mean, it doesn't take that long, but it works quite well for at least like scoped research tasks. It can take like 2-3 minutes. At least for that scope task, like I found that it's often can be impressive.
And I think it goes to like the general point, right? Where so much of AI, I think, is not the AI itself. It's the interaction modality, and it's like how you're stitching together the functionality that you can, what the model lets you do, right? It's a more or less non-deterministic natural language programming suite, to use some words. But how you interact with it, what matters. And, the completely asynchronous workflows, it's not a person. It doesn't have judgment.
Yeah.
Right. Like there was a story that went around over the weekend or like end of last week, I think, of someone that tried an operator and like they paid $30 for eggs because they logged into Instacart with it.
Yeah.
It's like, okay, man, why did you log into it? It's like,
Yeah.
the AI can't save you from your own poor judgment, I guess.
Yeah.
But it can amplify it.
Yeah, a lot of times operator wants me to log into my Gmail, Google stuff, and I'm like, no.
It's like, no, man, that doesn't work for me. But I think this goes to, like, this is the terrifyingly generic point about this is just that these are tools. They're not a replacement for humans. They are certainly a replacement for like human work in many cases. And that has its own terrifying implications, but
not for human judgment.
Right. I understand why people get like all head up about all this. It's just, I wish we could all be a little more like intellectually honest about the field or like what is actually happening here, right?
Yeah. To answer your question from before, like you asked, how do you cut through the noise? So another angle on it is I actually encourage all of my clients to not use jargon as much as possible in meetings. So like things like agents. I don't allow people to say the word agents. I just say like, you're not allowed to say that word. Like, let's talk about what you're actually trying to do. A lot of times people, once you introduce the word agents, it alienates all the non-technical people. And there's like a lot of times the job to be done is not really that technical at all. It's like, hey, we need to write a prompt. And what I found is, and I'm talking about jargon and all kinds. So like agents, like, okay, what do we need to do next? Like, what is this meeting about? Don't just say the word agents, like, do we need to like write a function, like have some tools that does web search? So we're working on, retrieval, or we're working on search, or we're working on, or we're just working on a prompt. Same thing with like terms like RAG. So I make sure people say, instead of RAG, say, hey, we need to give the language model the context that it needs to make a good decision. It's just like tell people to rephrase it that way. And then a lot of teams, like, they don't have engineers building everything. Like engineers are not the domain experts. Like for developer tools, you can say engineers are the domain experts. But like in a lot of cases, like engineers aren't the domain experts.
Mm-hmm.
And so the people writing the prompts and things like that, they're not developers. And so when you start throwing unnecessary jargon everywhere, it alienates those folks and it kind of doesn't bring clarity. And then also, like, I find that when people use jargon unnecessarily, that's the one way to smell BS. Like, you have to look into, like, what is it that you're actually doing? Like, don't just use this term, like agent. Like, let's drill into what do you mean by agent?
Yeah. We're going to unleash a swarm of agents. And it's like, well, it's hilarious because like I took statistics in college and like, I know when you have like a failure rate and you multiply it, like it takes a very short amount of time before everything is wrong all the time, always. And like, yeah, it's very funny seeing that kind of like you want to put something in there that can like multiply its failure rate. And like, actually, I think one of my favorite article to date on this topic is the Anthropic article about patterns in building agents and workflows. And they very cleanly distinguish between like, okay, you might make several requests to an LLM in the course of like a feature doing a thing. But like, if you can Like if you know how many requests you're making, like that's not an agent. That's just a workflow. And there's nothing wrong with that. It just, instead of calling the LLM once, you call it 5 times or however much. And that's like very neatly bounded. And an agent is a thing where it's like, well, you don't know how many times it's going to make however many calls it needs to make.
Because the LLM is going to decide what calls to make.
Maybe, yeah. And as they work through this article, like the patterns for agents are much more like weird and complicated than they are for workflows, because workflows are like substitute an LLM with any other like black box piece of tech, like a cloud service. Like it's very strongly analogous to any other software that you would build. It's just, now you have an LLM in the mix. And like, if you frame it in that sense, I think a lot of people building this stuff can make more sense out of it. But you throw an agent into the mix, they're like, yeah, there's this thing that's just going to run and do some stuff. And we need to determine what its exit criteria is and like what success means and what failure means and like all the variations thereof. And I would argue most teams, especially if they don't have domain experts in the room, are just not set up to actually define that.
So actually, this does lead me, I think, to an interesting question, which is the one piece of critique that I think is really applicable is because AI doesn't have judgment, it can't say, I don't know, right?
I mean, you can ask it for a confidence level and it can give it to you.
Yes, but the way that a lot of these systems are designed is...
You have to ask it or it'll just make something up usually.
It does make something up very well.
Yeah. I mean, it can tell you it doesn't know, but it's less likely to say that, I think.
Yeah, the thing is it's for a variety of reasons that I don't fully understand because I am not an ML scientist, like the system is designed to give you output. And because of the way it works, because there's not, even in quote unquote reasoning models, and I do think that there's probably arguably things that chain of thought will get us towards a like I don't know state for LLMs, but I do think that there's the only way to really counteract that in production systems especially is to go back to the start of this, observability, right? Like the machine won't tell you it doesn't know, but you can observe independently that it doesn't know. And I think one of the things that is a really underexplored area of LLM observability is being able to communicate confidence, being able to communicate these sort of observability measures back to the end user.
Yeah, I think one way that I like that people are doing this is like citations. Because you have to check stuff. And so, yeah, when you have citations, it's really helpful.
Yeah, I like the citation stuff. I think like chain of thought, I think has a lot that can go there. There was a really interesting paper that I think Philip maybe shared with me recently about embedding confidence in the token outputs.
Yeah. That's also like kind of an explore. Like I'd even thought about that like several years ago of like, okay, well, yeah, as Hamel was saying very, very early on, these things are inherently stochastic. So like that implies some kind of confidence score. Whether the system is aware of its confidence of its own answer is a wholly separate question, but like there is some kind of confidence involved.
Okay, so there is a confidence score. There's things like perplexity, which is like when a large language model is conducting inference, it's giving you one token at a time. And when it's doing that, there's a probability associated with each token that it's given you. And it's basically sampling those tokens according to the probabilities. And so if a large language model is giving you something with like a very low joint probability, that's something that is an output that would have surprised the model, like surprised even like another LLM maybe, or even like that, it's just, and so it's an interesting bit, like there's like an insult, because they're like, hey, like everything you say is low perplexity, meaning like you're not saying anything interesting. Whereas like your high perplexity, maybe you're saying something more interesting because like I can't predict these tokens that are coming out of your mouth. And so it's unclear whether or not like that correlates with, I mean, it may correlate with trust, but a lot of times like I want a high perplexity answer, like in the nature of what I'm looking for.
Right. I want the temperature.
It's almost like obviousness. How obvious is this?
Yeah, if it's like a set of words that are always in the training data, it's going to be low perplexity. If it's something that's like, wow, I didn't expect these tokens, that's high perplexity. So it's interesting. It's like, okay, like on one hand, yes, maybe you can say there's some correlation between high perplexity and some confidence, but on the other hand, I don't know, like, if you're really exploring something unique, maybe it is high perplexity.
And then at some point you get into the R microwaves problem, right? Where
The microwave problem?
turns out there's a subreddit where people just post role play as microwaves. And so all of the text is just the letter M over and over and over. And so when you start getting too many M's in a row, then the, next most likely token is another M and just...
And the rest of the output is microwave?
The rest of it is just...
People are so funny.
Which I should say has terrifying implications for anyone listening to this that is trying to do anything about training foundation models on observability data.
So it's time to wrap up then. Hamel, if there's one piece of advice you want to leave people with.
Yeah, look at your data.
Yeah, I knew you were going to say that. Fantastic. This has been great. Oh, and Hamel, how can people find you on the internet?
You can find me on Twitter, Hamel Husain. I also have a website, hamel.dev.
Hamel is Hamel.
Yeah, HAMEL.dev.
Awesome.
If you're looking for Philip on the internet, try the Honeycomb blog, honeycomb.io/blog.
Yeah, Hamel and Philip, thank you so much for both being on this show. This is a great discussion.
Yeah.
I really appreciate you coming on.
That's all we have time for today. If you're interested in being a guest on this show, or if you would like to suggest a topic, find us on Twitter at o11ycast. That's o11ycast. o11ycast is brought to you by Heavybit, the leading investor in developer-first startups. To learn more about Heavybit, visit heavybit.com.